Hello my dear students, how are you all? I hope all of you are doing good. So today is day 49 of our series 60 out of 16 KCET Mathematics in 100 days. Okay, so today is part 3 of Vector Algebra. Okay, in this session we'll talk about scalar multiplication of vectors. Okay, and we'll talk about the properties of that, and we'll again combine this with section formula, midpoint formula, and see results on that and solve questions on all these categories. Okay, so I've taken total of 8 problems today that will solve on these particular topics. So I hope you're prepared. Very simple session, very easy session. So please maintain the energy, solve all the questions with me. You don't need to take a pause or anything. If you start the session, please end the session, and let's complete the entire questions, all the questions in one go. Okay, so let me begin with the first thing. What is it? Scalar multiplication of vectors. Means how can we multiply a scalar number, 2, 3, 2 by 3, any number with a vector. Okay, so let's start. So first thing is multiplication of a vector by a scalar number. So first understand scalar number. Scalar number means that it will be a number, real number. It can be a fraction, it can be a negative number, positive number. Okay, actually the negative number will be helping us to identify what. So whether the number, the scalar that we're multiplying, if the, let's say we're taking that scalar to be lambda. Okay, for a vector given as vector A, I am considering the scalar that we are multiplying to the vector A as lambda, and if the lambda is positive, the resulting vector lambda A will be in the same direction of the vector A, and if the lambda is negative, if lambda, the scalar that we are multiplying, is negative, then lambda A, the lambda A will have a opposite direction, right? Will have a opposite direction to what? To the vector A, provided what? The lambda is less than 0. Correct? Okay, now so very simple, it's written over here. Let A be a given vector and lambda be a given scalar, right? A real number. Then lambda A is defined as the scalar multiplication of a vector A. Okay, now so if you see, so that's what I talked about here, the sign convention. If lambda is positive, you'll have lambda A in the same direction. If lambda is negative, then lambda times vector A will be in the opposite direction of vector A. Okay, now one more thing, if lambda is given by 1 upon magnitude of the vector A, if somehow we can write this, lambda is equals to 1 upon magnitude of the vector A, provided that vector A is a non-zero vector, means vector A magnitude is non-zero, it cannot be equal to 0, then only this condition is satisfied, right? Otherwise it will be undefined, right? So lambda is equals to 1 by vector 1 upon magnitude of the vector A, then lambda A will give me what? Will give me a unit vector, will give me a unit vector along which vector? Along vector A, along vector A. So lambda A represents the unit vector in the direction of vector A. Okay, it's missing over here, in the direction of vector A, which can be written like this, right? Lambda A, vector A upon magnitude of vector A. Okay, A, or I can replace this whole thing by this. So just remember this condition. If I can write lambda as 1 upon magnitude of a vector given as vector A, then lambda A will represent what? A unit vector in the same direction of the vector A. Now moving on. Okay, so let's understand this. Okay, the scalar multiplication, what it does. So we know that, right? I can write a vector, let's say, to write a vector AB, vector AB is there. Okay, vector AB is there of length, let's say I'm writing this as vector A. Okay, so I'm writing the vector AB as A. In that case, what I'll be having, I'll have this vector going from here, direction sense will be like this, and this length will be what, bacha? This will be A only, right? So if I'm writing another vector, let's say vector CD, okay, vector CD of what value? Of 1 by 2 of A, 1 by 2 of A. What it means? It means there is a scalar multiplied to the same vector, right? Scalar multiplied to the same vector. So I will have what? Will the direction change? No sir. Why? Because if lambda is equals to 1 by 2, and which is nothing but positive, means direction sense will remain same. So I can write this like this, okay, but the length will change, right? The length will change. Length will be what? Half of what it was for AB. So half of what it was for AB. So CD will be like this, and this will be what? Vector A upon 2. Vector A upon 2. Okay. Now if I have another case, let's say Mn, okay, and if it is, let's say, minus 1 by 2 of vector A, what will happen, bacha, in this case? The direction sense will also change. So I'll write it like this. mn will be like this. The direction will be over here, and it'll have what? Length of I don't have to write the negative sign there, right? I can write it like this, just 1 by 2 of a. If I'm talking about the only magnitude, but if I'm talking about sign, I write like this again. So negative. Why negative? You can see the sign is on towards the right in AB and CD, whereas in the case of Mn, the sign is towards the left. Because of this presence of, in this case, the lambda has become what? Minus 1 by 2, which is what? A negative value. So the length of the vector will change according to the scalar, right? Means the length of the vector AB will have a different magnitude because the lambda is multiplied being 1 by 2. If I'm writing, let's say 2, means the length will increase by 2 times, right? Writing 3, so that's how we can represent and understand the change that is causing or been caused because of the scalar multiplied to the vector that we had already. Okay, now moving on. Okay, I hope you understood the previous case. Okay, now we are moving on to properties. Okay, means what are the properties that are applied to the scalar multiplied with a vector? Whenever we multiply a scalar number, a real number, to a vector, what are the properties involved in that, and what properties are valid for that? The first one is associative law. Associative law means if I multiply n to the vector a first, and then I multiply the whole thing with another scalar m, or I can do first multiply mn together and then multiply this with the vector a, or I can do first multiply m with a and multiply n with the whole. The result will always remain same because m into n will be a scalar number, no? If that is multiplied with vector a, it will remain as it is. Okay, it will not be the case when we are multiplying vector to a vector. Understand that? Okay, for vector to vector, the result will be different. For now, since we are multiplying a scalar number, let's say multiplying 2 and 3. Let's say multiplying 2, 3 to the vector a. Correct? So I can write this as like this, or I can write this as 3 times of 2 vector a. Both will be what? Simply, sir, 6 times of vector a. Right? So whenever you are multiplying a scalar, this property, the associative law, will be valid. Okay. Moving on, distributive law. Distributive law. In this case, again you can say, so the vector can be distributed for the scalar also. It means, please have a look. If you distribute it like this, m plus n times of the vector a, what I'm going to do, multiply vector a with m first, and next what, the vector a with n. It means what, the vector is distributed over the scalars. Please understand, the vector is distributed over the scalars, sir. Correct? Alright, now in the second one, in this case we are distributing what, scalar over the vectors. Okay, so you can see here m times of vector a plus b is there. I can distribute this over the vectors. So m a vector plus m vector b. Correct? M vector b and m vector a. First case, vector is distributed over scalars. In this case, the scalar distributed over the vector. Both will be valid. So distributive property will also hold true for scalar multiplication of vectors. Chaliye. Moving on. And this is not scalar multiplication, means dot product. Means a scalar number, a real number multiplied with the vector. Okay, there is a difference. We'll see. That is actually vector multiplication only. Vector multiplication of two types: dot product and cross product. This is scalar multiplication, means multiplying a real number to the, or any real number to the given vector. Okay, there's a difference, bacha. Now, condition for two vectors being parallel. When can we say any two given vectors are parallel? Very, very important. This. Do you remember this? Also was the case for what? Collinear vectors, right? Correct. So two vectors a and b are parallel if and only if vector a equals to m times of vector b, where m is a scalar, whether positive or negative. Correct? Even the same case was there. Okay, we wrote it right now. AB like this, or I can write it like what? Mn like this. Even though it's going this way, doesn't mean it's not parallel, right? It is in opposite direction, but vectors are parallel. So that's why I can have the scalar m to be either positive or negative. Both will be a case for vector to be parallel, provided that this condition is true. What's the condition? One of the vector will be equal to the scalar multiplication of the real number with the other vector. Okay, chali. Now few notes. Vectors a and b will have same or opposite direction according to m. Correct? If m is positive, means same direction. If m is negative, then opposite direction. Okay. If a and b are two non-zero non-collinear vectors, okay, means if vector a is like this, let's say, okay, and vector B, let's say like this, vector B is like this, means they're non-zero and non-collinear, means not in the same plane like this. So whether one is going like this, other going like this, means they'll meet at some point. Okay, so very important, non-zero and non-collinear vectors are given for both vector A and B. Then for this to be 0, what is it? When a scalar multiplied with vector A plus a scalar multiplied with the vector B, this will only be 0 if what bacha, both x and y has to be 0. Means to make this sum x vector A plus y vector B to be equal to 0, I have to take x and y to be 0. Okay, provided what, vector A and vector B are non-zero non-collinear vectors, non-zero non-collinear vectors. Okay, chaliye, moving on. Okay, so very important to know over here, the most important thing to know over here is this condition, the sign condition, to understand whether if it is positive same direction, negative then opposite direction. You're going to use this in the questions also. That's why if the scalar is positive, the direction will not change, it will remain unchanged. If it is negative, it will be exactly opposite to what it was given in the question. Chaliye. Alright, now moving on to component of a vector. This is very, very simple. First component will be what? X component, right, across x-axis. Second will be what? Y component. Please have a look. So if I'm writing like this, a vector, okay, if I show you only for the two plane right now, this is the vector, let's say, okay, vector OA, okay, then I can write this vector OA x component like this. This is my y component, okay, x and y component. This can be written as either x, or I can write it as simply A, and this also as B. Okay, now if I'm talking about z axis also, you'll have a z component going inside like this. Okay, this will be what? This will be my C component. I can write it as simply what? X I cap, y z, sorry, not z, excuse me, y j cap, right? Yeah, so y j cap and k z cap. Okay, it's written ulta, right? Z k cap, no? Yes, z k cap. These are called what? The components of a vector. Okay, let me read through it. Let O be our origin, okay, and the point P having what coordinate? X, Y, Z. Having what coordinate? X, Y, Z for this point. Let's say I've taken it as A in this case. The coordinate is what? X, Y, Z. Very simple concept over here. Be any point in space. Let I, J, K be the unit vectors across x-axis, y-axis, z-axis. Correct? What is this? Please have a look. This is what? I, J, K is the unit vector across x-axis, y-axis and z-axis. Okay, we know that. Okay, then OP will be written as what? X I cap, Y J cap and Z K cap. See, X I cap, Y J cap and Z K cap, which is called the component form of vector OP. Component form of, okay. Now in this, very important to know only this part. These will be called as what? Simply if written without the I cap, J cap, K cap, it will be scalar components. And if you write with the I cap, J cap, K cap, okay, it will become vector components. Because I cap, J cap, K caps are what? They are unit vectors across the X, Y, Z axis. Okay, it means you're talking about the direction sense also. So that's why this will become what? The vector component, whereas just writing X, Y, Z will become what? Scalar component of the vector, what? Of the vector OP. Okay, chaliye. Sometimes X, Y, Z are also termed. Okay, now if you are looking for absolute value or the magnitude of this thing, how you write it? In the model, write like this: xi cap plus yz cap plus zk cap. And how you evaluate this value? Putting under root x square plus y square plus z square. So we're going to use this condition, so please have a look. Okay, I said very, very simple concept. These are very simple concepts. Okay, the chapter itself is very simple. Okay, now let's move on. Until unless the vector multiplication comes, then you have to, again, that is also very simple. If you remember the cyclic order, okay, we'll talk about that when we are doing that particular topic. Let's see this. If A and B are two given vectors defined like this, A1 I cap, A2 J cap, A3 K cap, and same for vector B is B1 I cap, B2 J cap and B3 K cap. Okay, then what? How do you write A plus B? Do you know the vector addition, right? We'll write for the like y component, means we'll take x component and add them, y component and add them, z component and add them. We know what is x component, this part. So we'll write like this: A1 plus B1 I cap. Same thing I can do for the j cap also. A2 plus B2 j cap, and same I'm going to do for the third component, which is z component. What is it, bacha? A3 plus B3 k cap. So for the vector, even this is a vector, right? I can store this another vector, let's say vector A, capital A. Okay, so for vector capital A, what is the x component? A1 plus B1. The scalar form. A2 plus B2, again the y component, and z component is A3 plus B3. Okay, in the scalar form. In the vector form, A1 plus B1 I cap, A2 plus B2 j cap, and A3 plus B3 k cap. Okay, now if I have to write for A minus B, how is it write it, bacha? Tell me. It will become A1 minus B1. Same thing with the minus sign. Please check. Okay, correct? Am I right? Now if you add both of them, let's see, if you add both of them, what are you gonna get? You're gonna get 2a over here, 2 times of a over here, right? Okay, what about this? Please check. If you add them, b1 will cancel. I can write here in I cap. Please check. It'll become a1 plus a1, so 2a1. What is this going to be? Simply 0. I don't have to write that. I can repeat it like this. J cap times also 2a2, right? 2a2. Because b1, b2 and b2 will cancel, right? Over here also. K cap times of 2a3. Okay, 2a1, 2a2, 2a3. Isn't the same thing? If I can multiply over here with 2, I have to multiply this, so 2 on the everything. 2a, 2a1, 2a2, 2a3. Please have a look. Right? Correct? Okay. So that's how we can multiply a scalar quantity to the vector components also in this form. What is the component going to be? X component is 2a1, y component is 2a2, and z component is 2a3 in the scalar form. Okay, so same thing is written over here. Please have a look. Lambda a equals to lambda a1, lambda a2, and lambda a3. Okay, so if you are multiplying a scalar number to the vector, you can multiply to the all the components individually, but you have to multiply all of them. Don't multiply with only one or only two. You have to multiply to all the 3 components. Okay, all right. Now if in this condition, if a and b were equal, please check. If a and b were equal means what? This whole thing will become equal to 0. This thing will become equal to 0 because a and b are equal. Then what will happen? Please check. For this, if I have on the left side, if I have 0, it means what? This everything has to be 0. Correct, right? If I on the LHS side, if I have like this 0 I cap, 0 means what? 0 I cap, 0 j cap, and 0 k cap. Right? It means a1 minus b1 is how much? 0. So what I get? a1 equals to b1. Correct, right? If this is 0, then it means what? 0 I cap plus 0 j cap plus 0 k cap, right? So compare the I cap, j cap, and k cap coefficients. a1 minus b1, 0. It means a1 equal to b1. a2 minus b2 equals to 0. It means what? a2 equals to b2. Correct? And if a3 minus b3 is equals to what? 0 over here and here, it means a3 equals to b3. It means whenever you have the vectors equal like this, means what? The component also has to be equal. What's the summary? If the vectors are equal exactly, then component has to be equal. Correct? That's why. Chali. How? We got it from here by comparing the coefficient of your unit vectors I cap, j cap, and k cap. Chali. Now if the last condition, if a and b are collinear, then what will happen? They'll be proportional. They'll be proportional. It means if it's collinear means it'll be 1, then if it is, let's say 1 and 2, then this also be 1 and 2, 1 and 2. Okay? So what I'm trying to say is, if let's say this is 1 and this is 2, and if I'm writing here, let's say 4, this will be 8. If I'm writing here 12, this will be 24. Means a1 by, so this ratio over here, no? The ratio, what is this, bacha? Please tell me. Ratio of the components. Ratio of components are equal when if the vectors are collinear. If vector a and b are collinear, then ratio of the components are always equal, or we can call it to be proportional also. Chali, that value I can take it as another constant lambda. Great. So second one, so third one, what is the, if I have to summarize, this condition was I can multiply a constant. If I have to multiply a constant scalar number to the given vector, I have to multiply to all the components, not even 1, not even 2. I have to multiply with all the 3 components x, y, and z. Second property was, if the 2 vectors are given equal, it means their component has to be equal. X component has to be equal to okay, x component, y component, z component has to be equal to each other, okay, for both the vectors. And the last one, if they're collinear, it means what? The ratio has to be constant or the same. We can also call it to be proportional. The ratio has to be constant. Understood? 3 properties, very, very important. Okay, very, very important. Please mark it. And please understand, looks very simple, you know, to see and revise through, but you'll use this in question solving, okay? That's why very important, okay? Multiplying a scalar, multiply with all of them. If it is equal, components will be equal, and the last one, ratio will be proportional. Moving on to the next component, next part, vector joining 2 points. So I think I've taught you this a little bit, but let's talk about this in detail today. So let's say I have 2 points written like this. 2 points like this. I can take coordinates are given P and Q. So let's take P. P to be what? They have given the coordinates to be x1, y1, comma z1. Okay. For this they have given x2, y2, comma z2. Now if I have to write the position vector, okay, from here I can go like this. What is this point called? Origin. What is this point called? This point is called as, again, yeah, so this is OP, this is OQ. Again, origin, what is the origin coordinate? 0, 0 and 0, correct? So they're asking us to find what? PQ. How will you find PQ, bacha? Tell me here. You're gonna get PQ by joining this. So the coordinate of, or the position vector of PQ, the vector PQ will be given by what? Tell me. Will be given by OQ minus OP. Please check. OQ minus OP. How come, sir? By triangle rule of addition. Please check. For this vector OP and for vector OQ, I have terminal vector of point OP, of the vector OP, same as the terminal as the initial vector of the point PQ. Please check. If I write here OP, vector OP and vector PQ, terminal point of the vector OP, isn't it same as the initial point of the vector OQ, PQ? It means the triangle law will be valid over here. Okay, and this is the resultant OQ. So you have to find the value of PQ. How will you find it? OQ minus OP. OQ vector minus vector OP. Yes or no? What is vector OQ? You write it with respect to what? X2 minus 0, right? X2 minus 0, right? So X2 I cap. For this, Y2 minus 0 means Y2 J cap. So I can write this like this. X2 I cap, Y2 J cap and Z2 K cap. I hope you agree. That's how we write, no? X2 minus 0, so X2 I cap, Y2 minus 0, so Y2 J cap and Z2 K cap. And now what about OP? With a minus sign will come because of the OP minus. You will get what? X1 I cap plus X2, sorry, Y1, right? Forgive me. Y1 J cap plus Z1 K cap. Take the difference now for the coefficients. Check the component. For I component will become what? Will become x2 minus x1. And this will become what? Please check. For J component you'll have y2 minus y1. And for K you'll have what? Plus K component will be Z2 minus Z1. Z2 minus Z1. Okay? Please check. X2 minus x1, y2 minus y1, z2 minus z1. You can apply the same concept over here also. P to Q, right? So x2 minus x1, y2 minus y1, z2 minus z1. We are getting directly from here, but how we are getting is this condition. So we write for OQ first, we write for OP next, okay? Then we take the subtraction, we get the same result which is written over here. Which is written over here. Now once you find PQ, you can find the magnitude of that, the whole square inside the root, right? Square root of x2 minus x1, whatever the component is, right? We learned this formula now over here. Please have a look. This one. Once you get the component, you can take the square of them to find the magnitude of the vector. Same thing. I get the component. What is the x component? x2 minus x1. What is the y component? y2 minus y1. Z component? z2 minus z1. So find the magnitude of the vector PQ. You're gonna get what? Square of the components. Sorry, square root of the square of the components. Square root of the square of the components. Please have a look. Okay, so I hope this is visible to you. If you want, so basically this is the vector of what? This is the vector form of OQ. OP is, this is OP. Okay, one second, I'll try it in the same color. OP. Okay, chali, great. This is it. Now moving on to Okay, so section formula, let A and B be 2 points represented by the position vector OA and OB. Okay, so let's draw the points. Let's see bacha, how will it look like. So the points are A and B, so let's draw the points here. A here, B over here, from this point, like this. This is the position, this is the origin. Okay, this point is A, this point is B. Okay, all right, this is the vector. This vector I can write it as, for point A I can write the vector to be vector A like this. Okay, and for point B I can write the position vector to be what? Position vector is B like this. Okay, and the vector AB is given over here. So what is this? So we're looking for section formula, means we're looking for a point P on AB, point P on AB which divides the vector AB. Okay, which divides the vector AB in the ratio M to N, M to N, forgive me, M to N. Okay, and we are looking to find the position vector R of that, means R is my unknown. I'll repeat, what's the question statement? So we are looking to find the position vector of the point P which divides the vector AB in the ratio M is to N. What type of division is this? Internal division. What type of division is this? Internal division bacha. Okay, chali. So all right, now so one thing we can see from here directly is AP to PB. If I write in the vector form, please have a look. AP to PB is equals to what? M by N, right? M by N, right? Okay, now what is it? If I cross multiply, I get this whole thing as N times of AP, N times of AP equals to M times of PB, M times of PB, correct? Okay, now in this situation, how would I write AP as? Please check. Will the triangle law will be valid of addition? How would I write OA? OA vector will go like this. Okay, OA vector will go like this. All right, AP is over here and PB is over here. Great. Now please check. So if I write it like this, N times of AP. For AP, what I'll write, bacha? Please check. A is the common point. Okay, for the vector OA and AP. It means what? It means I can write this A as the terminal point of the vector O and also the initial point of the vector OP. So this will become what? Tell me. The resultant vector will be what? R equals to AP plus OA. Okay, so I'm looking to find AP, right? So AP will be R minus A. AP will be R minus A. Please have a look. If this R is resultant vector for the triangle OAP, then I can write this R to be this OA plus AP. So AP will become what? R minus A. Same thing is written over here. Same way I can write for M also, for a PB also. What I'll write, bacha? B minus R. Please check. B minus R. How come, sir? For the triangle OPB, P is the common point, right? P is the common point, which is what? The terminal point of the vector R and initial point of the vector what? PB, correct? So B is the resultant vector. So B will become what? R plus PB. So what will be PB, bacha? B minus R. B minus R. Okay. Now I'll write this thing over here in the next slide. N times of R minus A. N times of R minus A equals to what? Please check. Equals to M times of B minus R. Please simplify this. NR minus NA and MB minus MR. Okay, bring this thing over here and this over this side. What I'm gonna get, please check. N vector R plus M vector R equals to M vector B plus N vector A. Okay, I can take R vector common over here. It'll become what? M plus N. This will be MB plus NA. From here what I get? From here I get vector R equals to MB plus NA upon what? M plus N. Upon what? M plus N. Same thing written over here. So this is the section formula when we're looking to find the points, any point P's position vector which divides the line or which divides the vector AB in the ratio M is to N. This is the position vector of the point P which divides the vector AB From where to where? In the ratio of m is to n, given by this condition. Same thing is written over here. mb plus na upon m plus n. Okay, very simple. Now I can have same, section created externally. I'll show you the diagram, but you have to do the proof from your side. Okay, external division. How will the diagram look like in this case? Please have a look. Point A over here, point B over here, origin at this place. So vector A, vector B, and this time the section is what? Outside. So P will be outside, creating a section. What is this going to be? Again, we are looking for the resulting vector R, which creates a section of what? M. This will be what, bacha? M. What will this be, bacha? N. This will be N. So again we have what? Same condition. I'll write this. Yeah, it's written over here. AP to BP will be what? AP to BP this time, not PB. Please check. I'll give you the direction sense also. So OA is like this, OB is like this, OP is like this, okay? AB is like this, and BP is like this. Okay, so same thing you have to use. AP to BP equals to what? M by N. Solve this, substitute the value of AP. What will AP be? Please check. AP will be what, bacha? AP will be right in terms of this thing. Okay, A, B and R. Alright, A, B and R, and same way, right, BP also in terms of A, B and R. Simplify, you're gonna get this condition. Okay, you're gonna get this condition. Alright, so if you use this, you're gonna get the same result which is given over here. How will you get it? I will not solve the exact statement, I will not get all the result, but I'll show you how to do it. Okay, so please have a look, bacha. So if I write it like this, n times of what? AP is there, right? N times of AP is there. How can I write AP? AP is nothing but, okay, so if I write this point to be O, the origin point, AP will be what? OP minus OA. OP minus OA, okay? So I write it like this, n times of OP minus OA. How much is that? Tell me. N times of what is OP, bacha? OP is R. Minus OA is how much? Minus A. This is for NAP. Same way I can write NBP as M times of vector BP as, so M times of BP will be what? Again OP minus OB. Vector OP minus OB. How we are getting this? By applying the triangle law of addition. Please apply and get it. Okay, so I can write here OP was R, and with what I'm going to write? Minus B here, right? So please solve this. You're gonna get the same result. Okay, solve this, you're gonna get this result from here. Please check. Okay, all right. Okay, so let's move on. So corollary, midpoint formula, very simple, sir. Same thing. In this case the section is what? 1:1. The section, that means the P which is creating section over here, P section was what? M is to N, right? This M is to N is what? This was for point A, this was point B. This M is to N is what? 1:1. 1:1. Okay, so I can just substitute M as 1, N as 1. I'll get the answer to be vector A plus vector B upon 2. Vector A plus vector B upon 2. Okay, then the position. So this is very simple, very simple. The position vector of the point P, which is creating a midpoint for the vector AB, will be given by vector A plus vector B upon 2. Simple enough, very simple. Moving on. Now few notes, last few concepts. If A, B, C are the position vector of the vertices of a triangle, then the position of what? Centroid. The position vector of what? Centroid will be given by A vector plus B vector plus C vector by 3. Vector A plus vector B plus vector C by 3. Okay, where what is A, B, C? A, B, C are the position vector of the vertices of a triangle given by triangle ABC. Okay, so this is what? The position vector of the centroid, vector A plus vector B plus vector C upon 3. Okay, now A, B and C are the sides of a triangle. Let's see. If I have like this A, B, C, okay, and vector AB is given as vector A and vector AC is given as vector A, then the median drawn from the vertex A will be given by vector A plus vector B upon 2. Please check. Vector A plus vector B upon 2. If AB and AC vector is given as vector A, please check, vector A and vector B, vector A and vector B, then the median through the point A will be given by, this is the midpoint, okay? Application of what? Midpoint formula only. Please check. Alright, great. So moving on to the questions now. First question, let's see. If a unit vector A makes angle pi by 3 with I cap, means they're talking about the component, okay? So x component will be what? Pi by 3. Okay, what is the vector now? They've given here. The vector is unit vector, okay? Means the magnitude is what? 1, okay? Now pi by 3 with I cap, pi by 4 with j cap, and an acute angle theta with k cap. So with the angles known, basically my alpha is given as pi by 3, beta is given as pi by 4, and gamma is given as theta. Can they write direction cosines? Yes sir, we can write it. So please check. Cos alpha will be cos of pi by 3, correct? And cos beta will be what? Cos beta will be what, bacha? Cos of pi by 4. Okay. And cos of gamma will be what? Simply cos theta. We know what? We know the property L square m square plus n square equals to 1. Put the values here. So cos square of pi by 3 plus cos square of pi by 4 plus cos square of theta is how much? 1. Pi by 3 means 60 degree, right? So what is the value over here? 1 by 2. So 1 by 2 square. Pi by 4 means what? 1 by root 2. So 1 by root 2 the whole square. This will remain as it is. So cos square theta equals to 1. How much is this? So 1 by 4 plus 1 by 2 plus cos square theta equals to 1. Okay. Now if you simplify this, you're gonna get what? Please check. You're gonna get cos square theta equals to 1 by 4, right? Correct? Please check. 1 by 2 if you take on this side, 1 by 2 will become what? 1 minus 1 by 2. 1 minus half will be what? Half. Then if you take 1 by 4 on this side again, half minus 1 by 4 is how much? Again 1 by 4. So if cos square theta is 1 by 4, please check. If you're not sure, please solve and check this last step. So cos theta will become what? Cos theta will become 1 by 2. We're taking only positive. Only positive is considered over here. Okay. Cos theta will be pi by 2. 1 by 2 means theta will be what again, bacha? Pi by 3. Okay. So if you're looking for what, find the components of A. So vector component A will be what? What's the magnitude? 1, because they have given it as unit vector. It will be what? Simply cos pi by 3, cos pi by 4, and what is it last one? Cos pi by 3 again. What is the answer? 1 by 2 comma 1 by root 2 comma 1 by 2. I cap, j cap, k cap. If you want to write it as I cap, j cap, k cap, right here, plus k cap. Please check. Okay, great. All right. So 1 by 2 I cap, 1 by root 2 j cap, 1 by 2 k cap is my final answer. But they're not asking the vector; they're asking only the component, right? So we don't have to write this, bacha. We don't have to write this. We don't have to write in this format. Just the component. This is the final answer then. This is the final answer over here. 1 by 2 comma 1 by root 2 comma 1 by 2. Okay. So let's move on to question number 2. Find the position vector of a point R which divides a line joining the 2 points P and Q whose position vectors are I, J, K. Okay, I 2 plus 2j minus k cap and minus I plus j plus k cap respectively in the ratio 2:1. Section formula. Okay. First of all, this is your homework. Please solve and give me the answer. Solve and comment your answer. Okay, I'll do the first part. Internally, what is the formula for internally? If you remember, it was the resulting vector R. The resulting vector R. What is it? It was the position vector of the point P. Remember, R was the position vector of the point P, which is creating the section of the vector AB. So R was given by MB vector plus N vector A upon M plus N. Let's write the vectors first. What is my vector A? Vector A is I cap plus 2j cap minus k cap, and vector B is what? Vector B is minus I cap plus j cap plus j cap plus k cap plus k cap. All right, now use this in this condition. What is M? M is 2, N is 1. Please check. M is 2, N is 1. Use it over here. The position vector of R, which is what? The point which is creating the position vector of R is what? Point which is creating the section 2:1. Okay, so M will be what, bacha? 2 times of B, right? So minus I cap plus J cap plus K cap, okay, and plus N means 1 times of B. So 1 n times of A. So I cap plus 2 J cap minus K cap. Please cross check the solution because I might make any mistake in the sign. I'm not trying to, but if I make, let me know in the comment section. So minus 2 I cap plus 2 J cap plus 2 K cap, bacha, minus, okay, plus simply I plus 2J minus K upon 3, right? So what is this going to be? Please check. Minus 2I plus I. So simply minus I. So minus I by 3. 2J plus 2J. So plus 4J by 3. 2K minus K. So simply plus K by 3. This is the position vector of which point? Of the point P, okay, given as vector R. Final answer. Please check. Please check. Okay, I hope this is visible to you. Minus I by 3, minus I cap by 3 plus 4J cap by 3 plus K cap by 3. Because why is 3? Because M plus N is what, which are 2 plus 1, which is 3. Simple problem. Internally part I've done, like no, the internal division I've done. External division you have to do from your side. Please solve and comment your answer. Chaliye, moving on. Question number 3. Question number 3. Find the position vector of the midpoints of the vector joining through. This is very simple. How will you write this? Check me. Please tell me. So this will be very simple. If I write OP, it will become what? 2I cap, 3J cap, plus 4K cap. Same way I can do what? OQ will be what? 4I cap plus J cap minus 2K cap. We're looking for what? Midpoint, right? Midpoint will be what? Let's say simply adding them. So vector OP plus vector OQ upon 2. Please have a look. 4 plus 2 is 6I cap. 3 plus 1, 4J cap. And 4 minus 2 plus 2K cap. Divide everything by 2. How much is it, bacha? My vector R will be given by 3I cap plus 2J cap plus K cap. This R vector is what? Is the position vector of the point P, which is the midpoint of the vector joining the points P and Q. So basically midpoint of the vector PQ. Okay, great. All right. So now moving on to question number 3. I hope this was easier. I hope you understood this. Very simple, right? Just add them and divide by 2. Great. They have given the coordinates. I got it with respect to origin. I got the position vector as the subtraction of the points, the coordinates, the components of the point P and Q with the component of the point origin. Okay, great. Question number 4. So that the points A, B, C with the position vectors given like this respectively form vertices of a right angle triangle. Okay, a good question. Let's draw a right angle triangle first. Like this. Okay, let's say this is A, this is B, and this is C. What is A, bacha? A is over here, 3I cap minus 4J cap. Okay, minus 4K cap. What about B? B is 2I cap minus J cap. Okay, B is 2I cap minus J cap plus K cap minus J cap plus K cap. What about C? C is simply I cap minus 3 J cap minus 5 K cap. Okay, this is what? This is the position vector of the point ABC. Means somewhere there is an origin. Somewhere there is an origin. So if you join this origin with the point O, OA, OC, and let's say somewhere like this OB. Okay, if you join it like this, then what you're seeing over here, the vectors are the position vector of the point ABC. Okay, but to find the value, we have to prove what? To find the value of the length. Okay, we have to prove what? Basically, what are you looking to prove? We're looking to prove that this side, one of the side square has to be equal to sum of the squares of other two sides. Pythagoras theorem we have to prove. Okay, now Going into that, I will need to know what? I will need to know the vector of AB, the vector AB length, vector BC and vector AC. How to find vector AB? Please check. Okay, please. Sometime what happens now, you'll just take this AB, BC and AC and square it up and get the wrong answer. We have to find the value of vector AB, sir, first. How will you find vector AB? Let's say this is point over here, O. Okay. How will you find vector AB? It will become OB minus OA. It will become what? Vector OB minus OA. Right? So please find. What is OB? 2i cap minus j cap plus k cap. This is vector B, bacha, and this is vector A. Okay. Now do the subtraction. 2i cap minus 3i cap. So minus I cap. Next is what? Minus j cap minus 4j cap. So plus 3j cap. Okay. And k cap minus 4k cap. So plus 5k cap. This is just the vector AB. Okay. Next I'm going to do what? Find vector BC. Find the vector BC. Okay. Now if you do that, please check. 2i cap minus I cap. So for that I have to do what? OC minus OB, right? For BC I have to do what? OC minus OB, right? So what I'm going to do? I cap minus 2i cap. So minus I cap. Minus 3i cap minus j cap. So plus will become what? Minus 2j cap. And minus 5k cap minus k cap. So minus 6k cap. Right? Now check the last one. CA. Vector CA. In this case, we have to subtract from the A side. 3i cap minus I cap, bacha. Please check that I'm writing the final answer. 3i cap minus I cap is what? 2i cap. Minus 4j cap minus 3k cap. So minus j cap. Okay. Minus 4 plus 3. Because the minus of minus will become plus, no? So minus 4 plus will be minus j. And minus 4k cap minus 5k cap. So it will become plus again. So plus k cap. Okay. Have a look. Are these the two lines now? Okay. This is just to explain you how it was working. Great. Now we are going to find what? We are looking to find this value. AB vector the square. Check. Please check. The components square we're going to take. So minus 1 square plus 3 square plus 5 square. How much is that, bacha? 1 plus 9 plus 25. 1 plus 9 plus 25 in the root. So 10 plus 25 is how much? Root 35. Okay, this is for AB square actually. Let's see if you're looking for AB square, no? Take out the root. Okay, so 35 units. Okay. Now great. Let's find BC also. Same way. Vector BC square. How much that will be, bacha? From here I can find it out. So minus 1. X component is minus 1. So square plus minus 2 square plus minus 6 square. How much is that? Please check. 1 square is simply 1. 2 square is what? 4. Okay. And 6 square is what? 36. 36 plus 4 is 40 plus 1, 41. Okay. Now I have to do the last one. 2i cap. I'm getting this. I'll write it over here. I'm getting CA is what? 2i cap minus j cap plus k cap. 2i cap. How much is that? Minus j cap plus k cap. Minus j cap plus k cap. Find this condition again. Magnitude the square will become what? It will become 2 square plus minus 1 square plus 1 square. How much is that? 4 plus 1 plus 1. How much is that? 6. Okay. Now please check. What we are getting over here actually is AB square plus CA square, no? We are getting vector AB square plus vector CA square equals to vector BC square, right? Please check. Yes. So what are the values? 35. 35 is this. And how much is this? 6, and this is what? 41. Please check. 35 plus 6 is 41. So condition is verified. Means triangle ABC is right angled at A, right? 1 second. Right angled at A, right? Please check. AB plus CA is BC, right? So have a look. AB plus CA is BC, correct? So right angled at A. Right angled at A. Okay, please have a look. Yes. Okay, great. Moving on to this question number 5. The vector AB equals to 3i cap plus 4k cap and AC equals to 5i cap minus 2j cap plus 4k cap are the sides of triangle ABC, the length of the median through A. Very simple, right? This condition, same thing, sir. This one, sir. A, B, C, like this. This is the median, right? Okay, how will you find this? They're asking what? They're asking the length. Means what are they asking? Length means what? They're asking the magnitude. So what is they asking? They're asking us vector A plus vector B magnitude divided by 2. Divided by 2. So first you find what? Vector A and B. What is vector A? So vector A is given by what, sir? 3i cap plus 0j cap plus 4k cap. What's vector B, sir? Vector B is 5i cap minus 2j cap plus 4k cap. Again, sum will be what? Sum will be adding the components of I cap, j cap and k cap individually. So I get what? I get 8i cap minus 2, excuse me, minus 2, right? Yeah, minus 2j cap plus 8k cap. Find the mod, find the magnitude, bacha. How much will be? Please check. 8 square 64 plus 4 plus 64. How much is this? It's going to be 4 plus 4 plus 4, so 2. 6 plus 6 is how much? Is 12 plus 1, 13, right? Now we're looking to find what? Divide by 2. So your length of median through the point A will be given by what? Will be given by root 132 by 2. I can take 4 over here as a factor. So 4 times of, I can write what? 4 3s are 12 and 4 3 are 12 again by 2. Can I take 4 common again? Yes. 4 outside I can take, so it will become 2 if I come out of the root. 2 and 2 cancel. What is the answer? Root 33. Option number C. Please have a look. Option number C is the correct answer. Simple enough. Extremely simple question. This is what we know, right? The formula we know, but they're not asking just the vector from the point A, which is the median. They're asking what? They're asking the length of the vector. Means you have to find the magnitude first. Okay, so length. Please check. So answer is C. Excuse me. Okay. Question number 6. The vector having initial and terminal points as 250 and minus 374. Alright. Extremely simple question, right? So this is, let's say, 2, 5 and 0, okay, and minus 3, 7 and 4. I can write this position vector, right? I can write the position vector like this, no? Please check. A, B. So if this is A, this is B. What is vector A going to be? Vector A is going to be what, Bacha, tell me? 2i cap plus 5j cap. There is no k cap because of 0. What about vector B? Vector B will be so simply minus 3i cap plus 7j cap plus 4k cap. Yes, I'm looking for vector AB, right? I'm looking for vector AB, right? How do you write it? Please tell me. B minus A. Okay. If you don't want to do all of this, just subtract the coordinates. You're going to get the answer. That also is right. But the correct form of the vector will be in this way only. If you want, directly subtract this. Minus 3 minus 2. Sir, minus 5. Okay. This is the answer directly. 7 minus 5. Sir, 2. 4 minus 0. So answer is C, sir. Moving on. That's all. But if you want to write the steps, these are the steps. How are we going to solve it? Okay. But in KCET, you don't need to, right? But the concept has to be known. That's why I'm giving this approach as well. So B minus A, tell me here. B minus A means minus 3 minus 2. So minus 5 I cap. 7j minus 5j cap. So plus 2j cap. And 4k minus nothing. So means simply 4k cap. We can see the answer here. Answer is C, sir. Same answer, no? Yes. So when you subtract and get the answer, this is what it means behind. Okay, and that's what you have actually done to get it, but without knowing it. Okay, that's how we can subtract the coordinates and get the result. Chali. Moving on to the question number 7. 6 was very easy. Yes. If the position vector of the 3 consecutive vertices of parallelogram are given like this, okay, then the coordinate of the 4th vertex is, okay, 4th vertex we are asking. How will you find it? First draw the parallelogram. Okay, let's write it. Vector A will be I cap plus j cap plus k cap. Okay, and what is this? Consecutive they have given. Consecutive means I can write here next to each other I3j and 5k, right? 5k. And the last one, what is it? Tell me. B. What is C? C is 7i cap, 9j cap and 11k cap, right? 11k cap. What's D? I don't know, sir. So x, y and z. X, y and z. Okay, chaliye. So if you are looking to find vector, let's say AB, we know that for parallelogram, what will this be? Vector AB will be equal to what? Vector DC. We're writing AB, right? So DC. Okay, so how will you find it for AB? Please tell me. Subtract the coordinates. 1 I minus I. Okay, how much is that, Bacha? Tell me. Have I written it like this? Yeah. So it will be, please tell me, it will be 0. Okay, 0 I cap. And 3j minus j. How much is that? 3j minus j. How much is that? So simply 2j. And what is this? 5k minus k. How much is it? Sir, 4k. Okay, great. Same thing you can do. Same thing we can do for what? CD again. Please have a look over here. For CD, I'm gonna get what? Please check. 7i minus xi, right? So I'll write it as 7 minus x I cap. Next one, this is 9j minus y. So I'll write it as 9 minus y j cap. Plus sign is there. Or the last one, 11 minus 2. So how much is that? 11 minus 2 is 11 minus z, right? Not 2. 1 second. Looks like 2, right? Yeah. This is z, bacha. Okay. So 11 minus z k cap. Okay. Great. Now please compare. Okay, this is k cap, not visible like that. This is k cap. Okay. Great. So have a look. I can compare, no, because they are equal, right? AB DC equal means what? Two vectors AB and DC are equal means what? The component has to be equal. Okay. So please compare the first one. 7 minus x equals to 0. It means what? X equals to 7. Next one. 9 minus y equals to 2. 9 minus y equals to 2. I'm comparing the components. What is y equals to? 7. Last one. 11 minus z equals to 4. 11 minus z equals to 4. So what is z equals to? Z equals to 7. Z equals to 7. Great. So what is the coordinate now for D point? For D point I'm getting x is coming as 7, y also is 7, z also is 7. So 7, 7, 7. Answer is, my correct answer is what? D. Option number D. Please have a look. Alright. Simple enough. So just write all the coordinates. If you don't want to use the approach of vectors, write the coordinates and subtract it. Okay, and compare the, because what happens is the component has to be the same, right? If the vectors are equal like this, the component has to be the same. So vector AB, this is my vector AB, bacha. This is my vector AB, okay, and this is my vector CD. So vector AB and CD are equal means the x component will be equal, y component will be equal, and z component will also be equal. Moving on to question number 8, the last question of the day. If 3p plus 2r minus 5q equal to 0, then pq are collinear. Okay, we are looking for collinearity. Okay, what is the triangle A? So again, from here also we can say collinearity will be applied. Divide P and PR externally. Okay, we'll see that right now. Can we get it? Okay, so to check the last point now, I can do it like this: 3p plus 2r equals to 5q. Okay, so no, from here we are not getting anything like that. 0.5. How much is that? Q. No, sir. No sir. So we have to check for collinearity. Just 1 second. Let's see. So if the point, let's say P, Q and R is like this, PQ and R is like this, for it to be collinear, it means what? PQ vector has to be what? Some constant lambda times of vector QR. Correct? How do I write vector PQ? So PQ is going to be equal to what? Q minus P, vector Q minus vector P. Correct? And what is going to be QR vector? QR is going to be what, bacha? Vector R minus Q. R minus Q. Okay, we have PQR in the given statement. Let's see if we can use it to get our result somehow. So if I can write the PQ and QR in this way, something like a constant, I can get a result like this. So please check from here. So 3P vector plus 2R vector minus 5Q vector 0. Okay, if I get in this form, it means collinear. If not, then it will be a triangle. Chaliye. So let's have a look. So if I can divide this Q 3 and 2, I'll get what? 3P vector plus 2R vector minus 3Q vector minus 2Q vector equals to 0. Writing minus 5 as minus 3 minus 2. Bring this 3Q over here. So 3P vector minus 3Q vector plus 2R vector minus 2Q vector. Correct? Equal to 0 vector. Now just take 2 common here, 3 common here. 3 will be P minus Q plus 2 times of what? R minus Q equals to 0. Okay, now bring this whole thing over that side. I'm gonna get what? 2 times of R minus Q equals to what? Minus 3 times of P minus Q. I'm bringing this whole thing, please have a look, this whole thing on this side. Okay, great. Let me erase this part, not relevant. Okay, great. So I'm going to use this last statement now. 2 times of what I'm getting, R minus Q, right? Take a minus sign inside. I'm going to get what? 3 times of Q minus P. I'm taking this minus sign inside. It will become minus P plus Q. Now please check. 2 times of R minus Q is what? R minus Q is QR. What is Q minus P? Is PQ. So 3 times of PQ. I wanted to write PQ in terms of QR. I can bring this 3 over here. It will become what? 2 by 3 QR equals to PQ. So simply I'm getting what? My lambda in this case of 2 by 3. And this is the form of what? Collinear points, right? Collinear vectors, not points in this case. We are dealing with vectors. So collinear vectors, sir. Hence, point P, Q, R are collinear. Point A, option number A is correct. Because we got lambda, we got this in this form. Okay. How this? This is the statement of the collinear vectors, right? Great. So this lambda is coming as 2 by 3. It means we are getting the result point P, Q, R are collinear. If not coming like this, means we can say what? We can say it's not collinear, means P is somewhere here, Q is somewhere here, R is somewhere here. Will form a triangle. If it's collinear, means there will be no triangle, it will be a straight line. If non-collinear, means it will be a triangle. Okay. So please have a look. I hope this is visible. I hope this was easy to you. Okay. So this completes our session today, bacha. Okay. So we have done some good questions on scalar multiplication, on section formula and midpoint formula. Okay, and we talked about the properties, different properties associated with the section formula and midpoint formula also. So with this I would like to end the session. Keep working hard, keep smiling. I'll see you in the next session where we'll talk about the vector multiplication. Okay, so then we'll talk about scalar and vector product. So first session will be on scalar multiplication, means dot product only. So please, if you can, revise some things and come for the session. Anyway, I'll start from the very beginning and go and solve all the questions based upon all the concepts that I'm going to discuss in the next session. So for that, with that, I would like to end the session. Keep working hard, keep smiling. Okay, take care. Bye bye.